Welcome to another Alex Geometry Topic instructional video by Mr. Hardy. What we're going to do in this video is find the area of a rhombus using the Pythagorean theorem. In other words, they're not giving us enough information so that we can just do it by using the diagonals. In the previous topic, if you did that one, they tell us the diagonals, the distance of the diagonals, and we can solve it. Here they're doing something a little bit different. In a rhombus, so the whole thing is a rhombus, so that means that it's a parallelogram, but the sides are all equal, that these distances all equal on the sides because it's a rhombus. Okay, so WX, so from W to X, this distance right here is 25. And from W to V, this is 24. Okay, so if we just focus on this triangle right now, just this triangle, if we could find the area of this triangle, we could just double it. We could just, or not double it, multiply by 4 and get the area for the whole thing. So I'm going to just sort of say up here, the area for the total would be 4 times the area for, what do you want to call it? The example triangle. I don't know. Bad notation. But okay, so the area, that would be 4 times, but what is that? What is that area? Well, it's 1/2 the base times the height. So that's going to be 4 times 1/2 the base of this triangle. If we this is a 90 degrees. I'm pretty sure that's 90 degrees. So we kind of have a triangle like this. It's 90 degrees. So we know that this is 24 and this is 25, but we don't know the base. So that's a little bit of a problem. So I'm just going to say B for right now. Now the height, though, is 24. If we draw it that way, it's 24. So times 24. So our problem is we have to find the base. So that's where the Pythagorean theorem comes in. The Pythagorean theorem says that if this is B and this is A, then we know that A squared plus B squared equals C squared. Okay, so A is 24 squared plus B squared equals 25 squared. Okay, so let's see. 24 squared is 576. 576 plus B squared. And what's 25 times 25? 25 squared is 625. 625. Okay, so now we're close. We just need to solve for B. So first we subtract 576 from both sides. And I'm going fast, so I'm going to trust my calculator more than I trust me at this point. So I got 625 in, and I'm going to subtract, take away 576. That equals 49. Hey, that's a nice number. 49, because what do we know? We know that if we take the square root of both sides, we get B equals, the square root of 49 is 7. That's supposed to be a B. Okay, so that's what we wanted. Now we know that up here that this is 7. That's our base. Okay, so now that can go into here. So we get 4 times 1/2 times 7 times 24. Okay, so maybe an easy way to use your calculator is just this. It's going to be all of that divided by 2. There's a lot of different ways of thinking through the arithmetic on this. So, clear, 4 times 1 times 7 times 24 equals, divided by 2 equals 336. 336. Okay, so I kind of skipped, because I used the formula, I skipped finding the area of this. I just plugged it in. Okay, and that's why I have the 4. If we did just the area of this, it would be this part right there. I'm just curious. Now, clear. 7 times 24 equals, divided by 2, 84. So the area here is 84. So then we just multiplied it by 4. Or you could add it if you don't trust multiplication. 84 plus 84 plus 84 plus 84 equals 336. Okay, so it's area, and what are the dimensions? Millimeters, so it's millimeters squared. That's the area of the whole thing, area of the total. Alright, so maybe we should just try do another one real fast, see if we can go a little bit faster. Okay, so on this one, E to F is 15. And from D to G is 9. Okay? But because they tell us it's a rhombus, that also means this is 9. Alright, so once again, here's a triangle right here. This we can assume is a 90-degree angle. So if we call this, let's call this C, let's call this B equals 9. And then, so this would be A. Okay, let me just draw it right here. A, we don't know. B is 9. And C is 15. What we do know is A squared plus B squared, these sides, is equal to the hypotenuse. The diagonal there is C squared. So A is a variable, B squared is 9 squared, and 15 squared. Now I'm going to do, instead of multiplying this all out real fast, I'm going to say, well, A squared, no, let's do this. That's supposed to be a plus. So I subtract 9 squared from both sides, and I get A squared equals 15 squared minus 9 squared. Okay, and then I can take the square root of both sides. So I get A equals the square root of 15 squared minus 9 squared. Now if I use, this is kind of cool, if I can't use standard mode for the calculator, it won't really work, but if I use scientific mode, here's what I can do. I can say 15 squared minus 9 squared equals, and then I just take the square root, it's 12. So A is 12. So this distance now is 12, which is the height. That's what's important. So now I can find the area of this triangle right here. The area equals 1/2 the height times, or the base times the height, or the height times the base. So the height is 12, so 1/2, oh, oops, I'm going too fast. 1/2 times 12 times 9. So half of 12 is 6. 6 times 9 is 54. So the area of one, let's just say of one triangle, okay, so the area of all four, so if I wanted to get all of this area, I would have to double it. or not double it, multiply by 4. So there's 4 of them. Okay, and that's not too hard to do. I know that 4 times 50 is 200. I'll just do it right here. 200 plus 16. So 4 times 4 is 16. 4 times 5 is 20, plus 1 more. 216, and meters squared. Okay, so the high level view is, for these problems, you have to use the Pythagorean theorem to get the dimensions of one of these right triangles. Once you get the dimensions, then you use the formula to find the area of one of those triangles and then multiply it by 4. That's how I do it. Okay, so there's a couple examples for you. Good luck.